Welcome back to part 6 of the 2016 AP test. Now in 2020, because of the coronavirus, part B, the interval of convergence question, is not going to be given. So, so we're not going to worry about part B on this test, dealing with the interval of convergence. And also, the question here deals with a series. We're going to call it a polynomial for the 2020. I will fix this in a future video, correlate to future tests. But for now, we are just looking at this as a Taylor polynomial, which approximates a function. Now, a Taylor polynomial, you might remember, is given by this little equation right here. How we generate Taylor polynomial. Now, you should have this for the test. You will need to know this. It was the fn of c over n factorial times x minus c to the n. This is how we generate a Taylor polynomial. And that's what they're wanting us to do here, right? The first 4 non-zero terms of a Taylor, and in our case, again, a polynomial. Now, they tell us the value of the function at the first, and they tell us the value of the derivative. But for anything with a power greater than 2, we're told to use this formula. So this right here is generated by the equation that they give us. And that's all that really means for us. So the first thing we have to do is go ahead and list it out. F of 1 is 1. They tell us that. The value of the first derivative at 1 is negative 1/2. So here n is 1, here n is 1, right? When n is 2, now we have to use our formula when n is 2. That becomes negative 1 squared times 2 minus 1 factorial over 2 squared. And if you simplify this, we just get 1 over 4. Sorry, that is not a negative there. That is not a negative. So let's get rid of that right there so it doesn't look confusing. Okay? Now, to get the value at the third derivative, because I want 4 non-zero terms, 1, 2, 3, 4, I'm looking at my third derivative. If I plug it into my equation, we get negative 1 cubed, 3 minus 1 factorial over 2 cubed. And if you clean all this up, you're going to get negative 2 over 8. Right there. And now we have to generate our polynomial. So now we use our function. So, and here's 3. So the third degree Taylor polynomial, it will be approximately, remember it's a polynomial, so we're going to say approximately our first term, which is 1. Here n is 0, so I don't have to worry about the rest of it. But I'm going to go minus, now I'm letting n equal 2. So we're going to get this negative of minus 1/2. But now I got to plug in here over, whoops, sorry, here n is 1, sorry about that, over 1 factorial, x minus 1 to the first. Go to the next term, plus, this now becomes 1/4 over 2 factorial. I'm using my rule here. X minus c, which is 1, squared. And then now I go to my third one, and that becomes minus 2/8. There it is, minus 2/8 over 3 factorial, because now n is 3. X minus 1 cubed. And we're going to stop there because that's our first 4 non-zero terms. We do, of course, have to clean this up a little bit, not too much. We're going to get 1 minus, this just becomes 1/2 x minus 1. We'll move this out of the way. Plus 1 over 4 times 2 factorial, whatever that is, right? X minus 1 squared. And then minus my last term, this becomes 2 over 8 times 3 factorial times x minus 1 cubed. And there's our third degree Taylor polynomial right there. And let's take a look how they score this. You will get 1 point for the first 2 terms, 1 point for the third term, and then 1 point for all the other terms. 1, 2, 3. So you would get 3 points for this question on the AP, possibly 4, okay? All right, try this one again. It's really easy to generate, okay? Go back and do this one again. All right, so let's go ahead and do question C. And we're not going to do question B here. So for question C says, the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms. So now they're just saying it. Remember, my polynomial, 1.2, I just plug it all in. And let's take a look here. It's going to be 1 minus, if I go over here, 1/2 x minus 1. So the 1/2 1.2 minus 1 plus, go back, 1 over, can I just write that as 8? 1 over 4 times 2 factorial is just 8. So 1/8, 1.2, whoops, let me erase that real quickly. 1.2 minus 1, and it's 2 now, because right here, n was 1, minus, and let's go over to the next last one, 1 over, that becomes 1/4 if I reduce that, so that becomes 1 over 4 times 3 factorial, 1.2 minus 1 cubed. Do not touch it. The AP won't make you touch it, okay? And again, this should be approximately, because it's an approximation. It's a Taylor polynomial, so be careful. That does need to be an approximation right there. So that would be your answer. Very simple. And that is actually worth 1 point. It's not worth much, just plugging it in. And then the last part, show that the approximation has an error of less than 1,000. So that has an error less than 1 over 1,000. And boy, well, to do that, we look at the series. We'll look at the series. Positive, negative, positive, negative. This is an alternating series. So this is our alternating series remainder right here. So what does the alternating series remainder say? That the error in the third term is less than or equal to the fourth term. So to get our fourth term, we just, to get our fourth term, that becomes, going back here, we're going to use our little formula right here. Don't worry about the negative there. So we just write here, 4 minus 1 cubed. So that becomes 4 minus 1. Yeah, 4 minus 1 cubed over 2 to the n, 2 to the fourth. And now I'm going to put this in, 1.2 minus 1 to the fourth. This is my fourth, or my next, I should say, term. That's my next term. And if you type all this in your calculator, what you wind up with is, or if you simplify all this, you get 1 over 3,000. Now, the AP doesn't expect you to know that. Honestly, they're okay if you leave it like this, but this is less than 1 over 1,000. So therefore, our error is correct. So we would say that the series, this is alternating series remainder, the series alternates, decreases in magnitude, and the limit equals 0. Therefore, our error, our error is less than 1 over 1,000 by the alternating series remainder. Now, I don't know if you can see this, but that's how we would answer that question right there. And you would get 1 point for this work and 1.1 to 2 points for your justification there. All right, so that's the series question from 2016. So definitely try this. One thing I would definitely know how to do, and this is what they're telling us in the AP stuff, definitely know part C and definitely know how to do part A. Those are the big ones. Part C, part D, I mean, they may or may not be, but definitely take a look at those, okay? So take a look at those two. All right, so that's the end of this lesson right here, question number 6. We will start to 2017 real quickly, so we'll see you then, okay?